Hey, I'm Kevin O'Connor, a solutions engineer here at HashiCorp, and today I'll be taking you through a demo of Vault-backed dynamic credentials for HCP Terraform, showcasing how you can enable just-in-time credentialing for deployments to AWS, Azure, and Google Cloud. Okay, so before jumping into the demo, we'll just do some background on a few things, right? For those who are not on Vault today, I want to just talk about some of the basics real quick. So Vault is highly pluggable. It has many different plugin mechanisms. So when we talk about Vault, right, first it has the central core, which has many different responsibilities, including sort of the lifecycle management and ensuring requests are processed correctly. But then there's many different extension points that allow us to fit it into our environment. We have the storage backends and the audit or logging backends, which are fairly straightforward, where Vault can store its data and log things. But what I really want to focus on are the authentication methods and secrets engines of Vault. All right, so these authentication methods or backends are extremely important and are essentially what allow clients to authenticate to Vault from a number of different known systems. So for example, if we're booting an EC2 VM in AWS, that VM might authenticate or would authenticate using our AWS authentication plugin, which allows us to tie back into Amazon's notion of identity, AWS IAM, right, to prove that the caller in this example is a web server. Likewise, we could have human users within our organization and tie their access to Vault to our internal organizational LDAP or Active Directory or Okta, right? Same goes for Kubernetes. We can tie Kubernetes workloads and have them authenticate to Vault using Kubernetes service account IDs. In this case, when we're talking about HCP Terraform, we're actually going to be using our JWT auth method that's based on sort of the industry standard OIDC for it to authenticate to Vault. But the goal of these authentication providers is essentially to take some system that we trust, right? Whether it's cloud provider IAM, LDAP, Kubernetes service accounts, OIDC, right? And use that to provide application or human identity. At the end of the day, that's what we're getting out of this is the notion of identity of the call. Then on the other end, we have our secrets engines, which is how Vault provides access to different secrets. These are the secrets engines or secrets backends themselves, and they come in a few different forms. One form is a simple one. The first up there, KV, right? Key value. I might just store a static username and password in there, and I'm providing the username and password. Maybe I'm versioning it, but it's stored in Vault and it's encrypted. It's a value that's encrypted at rest and in transit when provided to the requester, right? But probably the biggest use of these engines is the dynamic secret capability, where we're creating just-in-time credentials, like what we'll be doing today for our Terraform deployments. That same pattern of dynamic just-in-time credentials with short TTLs can also be applied to all of the major database platforms out there: SQL Server, MySQL, Oracle, Postgres, MongoDB, as well as messaging queues like RabbitMQ. And just real quick, a couple other things that Vault can do is around managing all of your internal PKI for your organization. So generating short-lived TLS certificates for kind of internal encryption between services, and Vault can help kind of auto-generate and auto-rotate them for your services. There's also an encryption as a service offering as well too, where you can send Vault a piece of data, it encrypts it, sends it back, manages all the keys, the lifecycle of those keys, rotating them. If you wrap keys with other keys, it understands those dependencies. You can also do some advanced things like format preserving encryption, masking, and tokenization, right? But really, the one thing I want to call out specifically when we're talking about this and how this applies today is that whatever the case may be, the flow follows the same pattern of something authenticating. That thing authenticates against a Vault role or with a Vault role, which has an associated policy that then allows it to access certain backend paths in Vault, right? So everything in Vault is path-based. It's really what I'm getting at here. So you could be a user logging in with your AD profile, and then you are provided access to certain backend paths and the secrets within in Vault. Like it shows here, if I am logging in, say with my AD profile, I may be just provided access to secret/Kevin/passwords, where passwords that I need to do my day-to-day are all stored, right? Or in our example, you may be a Terraform deployment and you're authenticating into Vault and are allowed access to certain AWS secrets engine backend paths, which contain or actually create AWS credentials specific to your deployment. So maybe we have an app and we call that app 123. And we've configured the AWS secrets engine at this endpoint of AWS/app/app 123. And when Terraform kicks off a deployment, it's able to authenticate to Vault and is provided access to this backend path for app 123. And let's say as part of that Terraform deployment, it needs VPC and EC2 access, right? And we want to provide it with the least privileged credential for that. In this sort of dynamic credential workflow, the credentials for the deployment to access AWS aren't actually stored within that backend path, but this path contains an AWS policy for an app 123 deployment, right? That would essentially give us privileges to do what we need to do in VPC and EC2 within AWS. So by reading from this backend path, when the Terraform deployment reads from this backend path, it kicks off a workflow where Vault then authenticates to the cloud, to AWS, and generates credentials based on a policy that we configured at this secrets engine path, right? So Vault essentially knows how to create cloud credentials. That's part of our sort of secret sauce. But what we need to tell it when we're configuring the secrets engine is what policy to attach to those credentials it's generating. Okay, makes sense so far. Move on, just a couple other things. Before diving into detail, I want to cover the overview of the flow for this use case and demo. So the vault-backed dynamic credentials refers to these Vault secrets engines that allow you to generate these credentials for AWS, Google Cloud, and Azure. The way it works is first HCP Terraform runs are authenticated to Vault using OIDC workload identity tokens. So you're setting up that JWT OIDC auth method in Vault and establishing a trust relationship between HCP Terraform and Vault. Then Vault uses the configured dynamic secrets engine for your cloud provider, AWS, Azure, or Google Cloud, to generate the short-lived cloud credential that's unique to the Terraform run. So that's what we're doing in step 2 there. Then the credential is injected into the run environment for use with the corresponding Terraform provider. It's essentially what's happening in step 3 there, right? And it's all abstracted away from the user, right? They're never being exposed to this. And then once the plan or apply is complete, that temporary Vault token and the downstream cloud credential are revoked to eliminate the risk of reuse, right? One of the main advantages, and part of the reason we're here, is that you don't need to configure OIDC on the cloud provider. Vault just uses the provider APIs to authenticate, which is especially beneficial for the Azure integration because Azure AD federated credentials currently don't support wildcards. So every unique HCP Terraform project or workspace or plan and apply combination would need to be explicitly bootstrapped, right? But Vault can abstract this away because it supports wildcards and can essentially map those to different Vault roles, generating scoped Azure credentials. Likewise, in an AWS multi-account scenario, every account would need OIDC setup, which we don't need to do here as well too, as Vault is using the AWS provider APIs. You're also centralizing all of your secrets management for cloud deployments into a single location, as well as having all of the other benefits that Vault can bring to the table, like PKI and dynamic database credentials and encryption as a service offerings, like I mentioned before. So that's high-level overview. We'll break it down now into parts. So how is this set up? So the first thing is in creating that trust relationship between Vault and HCP Terraform using OIDC, which is essentially accomplished through creating a Vault JWT role that HCP Terraform can then use when authenticating to Vault. So create the role in Vault, give that to Terraform to then use to log into Vault. Essentially, that configuration is ensuring that Vault will check that requests for dynamic credentials match the OIDC claims. And there's much more detail as far as the OIDC flow that you can get into if you'd like, but it's just kind of out of scope for what we're looking to do here today. Vault offers a lot of flexibility in determining how to map roles and permissions in Vault to workspaces in HCP Terraform. So if I have a workspace in HCP Terraform, well, I can have that workspace authenticate using a role specifically tied to that workspace only. So a very small security scope, right? So using the sub or the subject of the tokens bound claims, you can essentially ensure that it matches the configured HCP Terraform organization name or project or workspace that you're looking for, or any combination of those. So this is how you can be sure that your cloud provider only authenticates requests for specified projects and workspaces in your organization and lets you scope permissions on a per project or per workspace basis. Okay? So you can have one role for each workspace in Terraform, that small security scope, or open things up a bit and have one role for a group of workspaces or a project, like I actually have in this example, where this role actually grants access to anything within the test org and the project called test project, right? Where we've put wildcards for workspace and run phase. So this would provide access to essentially anything within my project called test project, right? Or you could open it up even more and have one role for all workspaces in an organization, right? Just wildcard the organization, which obviously may not be recommended, right? That'd be a very large security scope, but just to showcase the flexibility. Once you have that set up, now we need to talk about Vault to the cloud, right? How does that authentication happen, right? So you're going to need to configure the cloud provider secrets engine within Vault, right? And there's two ways of doing that. So historically, this required static credentials in Vault. So you would set up credentials in Vault that it would use to authenticate to the cloud. But more recently, we've released what we call plugin workload identity federation, which allows Vault to use short-lived credentials as part of this flow. So, for example, for AWS, if you had a trust relationship configured between Vault and AWS through Web Identity Federation, then the secrets engine can exchange its identity token for short-lived STS credentials needed to perform its actions. And the same goes for Azure and Google as well, too, through workload identity federation. Then we need to configure the cloud role for credentials to generate against. This is what I mentioned before. So Vault knows how to generate credentials, right? But we need to tell it what policy those credentials will have. So that's part of kind of your Vault admin's responsibility as well, too. Once they've configured the access for Vault to the cloud, then it's, okay, what permissions should those credentials have that it will be generating? And then from a user perspective, all they need to do is read from that role endpoint to be provided with short-term credentials, right? So in this case, a user in step 3 would be reading from that role endpoint that was previously configured, and they're provided with an access key and a secret access key to access the cloud that have a specific lease duration. In this case, it's quite long. It's 768 hours. In practice, you'd probably have this set at a few minutes, right? Until it's automatically expires. You also get a lease ID, so you can do kind of manual revocation. If you know the lease ID, you can extend leases and things along those lines. So looking at everything end to end real quick, just to recap, everything in Vault is path-based, right? So someone or something has rights to access a backend path in Vault, and in its most simple use case, they'd be provided with a static secret. In the case of our dynamic secrets engines, reading from a dynamic secrets engine backend path, specifically a role named endpoint, kicks off this flow where Vault then auths to the cloud provider and generates a set of short-term credentials based on the cloud policy assigned to that endpoint in Vault. Those short-term credentials are then passed back to the original requester or client. In this case, that's HCP Terraform, where they're injected directly into the run execution using the Vault provider for Terraform. Okay, so now let's actually get into the demo portion, right? I've talked through procedurally how this works. Now, practically, what did I have to do? Well, I did work through everything entailed in setting up those trust relationships between HCP, Terraform, and Vault and the different cloud providers. Specifically on the Vault side, that means configuring the secrets engines, creating the required roles and policies. And on the cloud side, it's more about creating the roles and maybe, service principals in Azure, right? Needed by Vault for accessing the cloud. So I think one of the best ways of looking at this is taking a look at my environment variable setup, which is key for how things are going to speak to one another, right? How are they going to auth to one another? So taking a look at how I did this for Azure, I'm just going to run through this real quick, and then we'll kind of talk through it. So we have our ARM subscription ID and tenant ID. That's what they say they are, where it is we're going to be operating within Azure. Then we have TFC Vault address, and that's the endpoint where Terraform can hit my Vault cluster. So that'll be the address of your Vault instance. Then we have TFC Vault-backed Azure auth, and that just needs to be set to true. That's a bool, right? It needs to be set to true, or HCP Terraform will not attempt to authenticate with Azure. Then we have TFC Vault-backed Azure Run Vault role, and that's the role to use in Vault. This is the role we are creating, or we are generating credentials against, right? So this has the cloud policy that will be associated with the credentials that we're creating. Then we've got TFC Vault namespace. That's the namespace to use when authenticating into Vault, where it is we're going to be operating in Vault. We have TFC Vault Provider Auth. Again, that just needs to be set to true. Otherwise, HCP Terraform will not attempt to authenticate to Vault. And finally, we have TFC Vault Run Role, and that's the name of the Vault role for Terraform to authenticate with, which in this case is TFC role in our example. So stepping through this, taking a look from the bottom and going up, when we run a Terraform apply or are looking to deploy to the cloud, one of the first things Terraform is going to look for are your cloud credentials. Well, guess what? We don't have them. Or more correctly, Terraform doesn't have them, but it knows that Vault has them because we've set the configured Vault provider to true, right? Essentially by setting that variable to true. So Terraform is going to need to authenticate to Vault to get the cloud credentials. And TFC role is what HCP Terraform is going to be logging into Vault with. And because of the trust relationship we previously set up, Vault is going to say, hey, I know this guy, and he's good to come in under that role and with the associated permissions that TFC role allows him to do in Vault. So whatever backend paths in Vault that TFC role can access will be available to this HCP Terraform run. And in this case, one of those endpoints that Terraform is granted access to is that Azure/creds/edu app role endpoint. And if you remember, that edu app role in Vault has the associated cloud policy, allowing it to, say, create VMs or change a network config that it's going to generate short-term credentials for. So Vault will say, okay, this run is requesting credentials to be generated with the cloud policy that's attached to edu app, the edu app Vault role. So Vault will auth to the cloud, create the credentials, and then inject them via the Vault provider for Terraform directly into the run environment. And we've got similar setups as well for AWS and Google Cloud. Don't need to run through this. It more or less follows the same pattern, although obviously there's slight differences. And then, of course, just wanted to mention, you can manage all of this with Terraform by using the Vault provider. So you can take an infrastructure as code approach to managing your Vault configuration, something that we recommend doing. You get all the benefits of infrastructure as code for managing Vault. So for Azure and GCP, I actually set this up manually, using the CLI and API, but for AWS, I set it up this way using Terraform. So let's take a look at a few things. So we have our workspaces set up in Terraform. So this is HCP Terraform. If I go into my K O'Connor project, and I have my K O'Connor organization, I have a project called Vault Dynamic Creds. We can see here I have individual workspaces for Google Cloud, AWS, and Azure. Let's just take a look at the Azure one, show the environment, the variable setup. This is what I showcased before. Take a look at Vault real quick. So I have a Vault cluster that's running in HCP Vault. This is the main dashboard. We take a look at our secrets engines. I previously configured the AWS, Azure, and Google secrets engines in Vault, along with the cloud policies that they will each be generating credentials for. If you're wondering why Azure and GCP are grayed out, it's only because they're not configurable via the UI. You can only configure them over the APIs, or AWS does have the capability to do it within the UI. So they are all configured the same. No need to worry about that. Now let's just step through the code real quick. So here we have just VS Code. We've got a few things going on. Let me just clean this up for a second. So here we have Vault Dynamic Creds HCP TF. This is my Azure deployment. If we take a look, we've got a couple we've got our organization and workspace called out for Terraform. We have the provider call out for Azure, and then we're really just deploying an Azure virtual network called My Virtual Network. On the Google side, it's fairly similar. We have our HCP Terraform and Google provider callouts, and then we're deploying a VPC network called Terraform Network. And then on the AWS side, it's a bit more involved. We have, if we take a look in Trust, we have all of the Vault provider callouts this is setting up my HCP Terraform configuration using Terraform. And then we actually have our Vault provider callouts here as well for setting up all the configuration for Vault using Terraform. But then what we're actually going to be deploying is located within infra, and we're just deploying an EC2 instance, essentially, right? We have the same kind of callouts here, just on the AMI we're using, and then our AWS provider. So as you can see, right, there's no credentials called out in my code. There, I can assure you there's no credentials I've exported locally, anything like that. Right. So let's go ahead and kick off these deployments, and then we'll take a look at the consoles of the 3 cloud providers to see what's going on. So here I have my, just so we're all on the same page, my Azure deployment down here. I'll kick off and apply. And then I've got, and I'm just doing a CLI driven workflow. This is leveraging HCP Terraform on the back end as remote state, right? But I'm just kicking off the deployment from the CLI. Likewise, you can use a VCS or API driven workflow and it'll work the same. Here we have our AWS deployment and our GCP deployment. So we can take a look at them within the Terraform console, head over to our Vault Dynamic creds, and we can see our Azure, we've already reached the cost estimation phase. And looks like we have as well too. So I'm going to go ahead and approve these. Right. And if you want to follow along within the console, we can see here, we're now running our applies. Same for, I'll just take a look at Google, right? Same for our other runs. And so these should just take a minute to finish, and then we'll head into the console just to look at a few things in terms of what's been deployed. So we're done in Azure. Fantastic. And we should be done in AWS and in Google shortly. There we go. Apply complete in AWS. And so if we head here, we can see, yep, we've been applied. So let's go ahead and while we're waiting for Google, and it looks like Google just finished as well too. Great. Let's head into the consoles now. So within Azure, since the Vault Secrets engine generates credentials within an Azure resource group, we can look at the resource group I created. In this case, it's called Vault Education, to see role assignments that are being created, right? And in Azure, access to resources is granted by creating role assignments, where you can then grant principal access to specific Azure resources. So all I'm looking to do here is kind of show some evidence of what's been going on in the background, what Vault essentially accomplished. So I'm in that resource group. We take a look at the activity log. There we can see there we go. So created a role assignment 2 minutes ago that was used to then create or update the virtual network. Fantastic. That's all I was looking for. Within GCP, I'm in IAM and then service accounts and then service account logs. And we should be able to see the service account keys having been created. So if I refresh this, let's see what we get. Fantastic, right? And this was just a few minutes ago, where we created a service account key that was used for the deployment, and then actually deleted it fairly quickly once the deployment was finished. And then within AWS, we are in IAM and then users, and actually created a user for HCP Vault Secrets engine. So let's go ahead and look in there. If we take a look at security credentials, we should see that these access keys, let's see, last used 32 minutes ago. I bet if we just give this a second, that should update. But if we take a look at Access Advisor, I want to show you what we're actually doing behind the scenes, right? We can see that this policy is tied to AWS STS. If we take a look at the policy, and this should actually open up the policy itself. We can see we're using STS assume role and calling on TFC role. Now let's actually take a look and see. We should have TFC role that's set up previously. Yep, and this has the policy that's associated with full access for EC2. Now, the one thing, this is saying that it was last used 33 minutes ago. I think this should actually update here in a minute to show that it was just used more recently. Looks like it's taken some time to update, but perhaps we can come back to this in a second. We'll just take a look within each of the consoles real quick just to show the resources that we have. So in Azure, if we search, see virtual networks, we can see we now have my virtual network that we were looking to deploy before. Within Google, if we take a look, what do we deploy? We deployed a VPC network. We have Terraform network that's been deployed. And then within AWS, we deployed an EC2 instance in US East 2. So we should be in Ohio. And we can see we have an instance running. We didn't give it a name. So that is the instance that we were looking for. So hopefully that's been helpful. Let's take a look once more within AWS to see if this has updated. Not yet. Interesting. Okay. Oh, there we go. Last activity 5 minutes ago. So it was just taking a little bit to propagate on the AWS side. Let's see if we look at security credentials again. Yep. Yeah. So security credentials last used 5 minutes ago. Beautiful. That's what we were looking to see before, right? So these are the credentials that Vault used to auth in and generate those short-term credentials. So as I was saying, hopefully that's been helpful and showcases, how you can securely provision resources to the 3 major cloud providers using Vault as a credential broker for dynamic just-in-time credentials. If you have any questions, please feel free to reach out or reach out to the appropriate account team that you have here at HashiCorp. Otherwise, have a great day and thank you so much. Take care.